So, just want to say that our story talks about a very famous neurosurgeon whose name is Oliver Sacks. Now, this book called Uncle Tungsten talks about his childhood when he was a kid who lived in London. And Uncle Tungsten is the name of his uncle, Uncle Abe, better known as, well, Uncle Tungsten because of his love for tungsten. Now, in these chapters, I do want to talk mostly about the love of chemistry and how trying just to enjoy chemistry itself. But in this book, they do talk about stories, and for example, I am going to include 3 chapters in this. For example, one is called Exile, and Exile, all it really talks about is during World War II, and I just wanted to say this does not include any chemistry, but it talks about how he was in a terrible boarding school, and even when he came and he got spanked with a cane, ate the most disgusting food, even though he's 60 at the time when he wrote the book. He says just these 10-year-old, when I was a 10-year-old, he says how much the memory still flood back to him. And even when he came back, most of his servants have left, mostly due to the expenses of the war and also the bomb damage. But let's get that out of the way and let's talk about the fun stuff. So, a chapter that does talk about chemistry, an ideal metal, and once you hear this, you already know that it has something to do with tungsten, Uncle Tungsten. And why is tungsten so good? Uncle Tungsten says in his own words that he sees it as a perfect metal. It is tougher than steel, and it keeps its strength in very high temperatures. And so, coming back from the war, young Oliver is very excited, and hopefully excited that his uncle is happy to have his own little protege back, who gets to look through at his experiments. Now, one experiment that they, just to start off, Uncle Tungsten throws a tiny nugget of platinum and says, "Here, catch." It's dense, right? And as little Oliver tries to pick it up, it is extremely heavy. And trying to show how dense it is, as platinum is a very dense metal. Now, I'm sure that we're all very familiar with iron by now, and if you didn't know, iron, when exposed to a long time of oxygen, starts to rust. Now, this is a chemical reaction because you change the chemical composition of iron, and once you add oxygen to it, it becomes rusty. And this creates iron oxide, which is a bunch of rust. Now, let's not get this confused with physical changes, because physical changes, for example, do not change the chemical composition. For example, if you were to melt ice and turn it into water, or heat up the water and turn it into water vapor or gas, this would be a physical change because you're changing the state of matter, but you're not changing H2O. H2O stays as H2O throughout the entire thing. You're just adding heat. Now, for this next experiment, just to relate with iron, aluminum also has the same effect with oxygen with it, just like how iron has with O2. Now, the only difference is it actually goes much faster. Now, I know what you're thinking. JP, I've never seen aluminum rust. Why is that? Well, if you wanted to know, it's because aluminum has a very thin layer, is exactly why it shines, of thick oxide around it, which protects it from oxygen all over, so that it's not able to touch or affect it. But Uncle Tungsten adds another metal called mercury. Now mercury, if you didn't know, is a metal that's basically a liquid at room temperature. And so when he adds this mercury to the aluminum, it slowly destroys the little air, and so once the mercury is poured over, there's now an opening that exposes the aluminum. And once it exposes the aluminum, it exposes it to oxygen, which rusts extremely fast, nearly seconds after they're done with the mercury. Now this clearly frightens young Oliver, but more intrigued than anything, because this is one of the most violent of all experiments. Next, he talks about light for the masses, which is the next chapter. And light for the masses talks about light bulbs. And as I said in my first video, Uncle Tungsten owns a light bulb company and uses filaments made of tungsten, because tungsten is a very good metal in this case. Now we explore some of the spidery web and very complicated filament types, but we also talk about this other kind of bulb that is called like a limelight when you heat a specific metal. Now this limelight is used in perhaps any kind of theater as well because of the way that it shows off. And no, it has nothing to do with lime. And soon, heating up all these metals would then produce oxides such as zirconia, alumina, thoria, magnesia, and zinc oxide. Now I know what you're thinking, zinc oxide, how come all of these? Is it perhaps called zincia? Well, even young Oliver asked this to his uncle, curious about it, but his uncle says no, it's never been called that. And then it also talks about mixtures of earths of these earths and perhaps with something else like some oxides. So for example, the mixture with thoria and ceria must exactly be 99:1 to make a very effective chemical reaction. Using a 98:1 or a 100:1 would not nearly be as effective as they discovered. And later it also talks about, well, hence the name of the title, about light and how Thomas Edison decided to use carbon filament because it would light up longer than any other metal and it would light for hundreds of hours. Now the problem was maneuvering this carbon to make some coils to help extend the light. But the problem is, whenever one would try to maneuver it, this would quickly snap the brittle carbon. So what Thomas Edison decided to do was that he would take perhaps some paper or maybe a piece of wood and he would burn it. And after he was done burning it, this small little exoskeleton of carbon was left, maneuvered in a way that he wanted, and he would put this inside of his lights, like so. And later, it'd be known to light up and do exactly what he wanted. So yeah, this is the end of my video. I do hope you enjoy, and I will try to do more of these videos, and hopefully you will stay tuned and you will watch all of them. Thank you.